Glucocorticoids are lipophilic steroid hormones that are released in an oscillating circadian manner. Paraventricular nucleus and the hypothalamus release CRH, which act on the anterior pituitary, releasing ACTH. ACTH travels to the adrenal gland and acts on the adrenal cortex, stimulating the formation of glucocorticoids from cholesterol. Once glucocorticoids are formed, they are free to act on multiple cells in the body. Glucocorticoid receptors are located in the cytoplasm and are bound in a complex with proteins that hold the receptor in a high affinity state. Once bound with the glucocorticoid receptor may do one of two things: transactivation or transpression of DNA segments known as glucocorticoid response elements, or GRE. Through transactivation, it can dissociate from the complex and form a homodimer, which results in the upregulation of anti-inflammatory molecules. Or, through transpression, it can form another complex with pro-inflammatory transcription factors, resulting in the downregulation of pro-inflammatory cytokines. The action that the receptor has in the cell is highly dependent on the cell and its physiological state. Thus, glucocorticoids can be used in the treatment of inflammatory diseases. One such disease is asthma, which is characterized by the inflammation in the lungs. Inhaled glucocorticoids are used in severe asthma exacerbation as a rescue medication. When inhaled, they rapidly enter the airway cells as they are highly lipophilic. There, they bind to nuclear receptors, and through glucocorticoid receptor complex, they alter the transcription of inflammatory modulators. Specifically, they inhibit the transcription of the genes for cytokines that are implicated in asthmatic inflammation and downregulate pro-inflammatory mediators such as interleukin 1, 3, and 5, and upregulate anti-inflammatory mediators such as inhibitory molecule for nuclear factor Kb1, IL-10, and 12, and annexin 1. Many different cell types also mediate inflammatory responses in asthma. Glucocorticoids also has direct inhibitory effects on many of the cells involved in airway inflammation in asthma, for example macrophages, eosinophils, mast cells, and dendritic cells. Of course, there are some side effects. Through the transactivation pathway, glucocorticoids can induce adverse effects such as triggering temporary or potentially long-term diabetes. Excess glucocorticoids can potentially also increase the transcription rate of genes that are responsible in producing enzymes that enhance glucosynthesis. Genes such as TAT that encode a hepatic enzyme responsible in the gluconeogenesis pathway have promoters which are activated by the glucocorticoids. With increased transcription rates of such enzymes, glucose levels rise in the body and potentially can cause diabetes. Through the transpression pathway, effects such as the suppression of the hypothalamic pituitary adrenal axis can take place. This can cause disorders such as iatrogenic Cushing syndrome and adrenal insufficiency. With prolonged use of glucocorticoids, there is a reduced general steroid production due to the negative feedback inhibition of ACTH release as well as CRF release. While the exact mechanism is unknown, the reduced ACTH can also lead to the decrease in osteoblast activity, which are cells responsible for the formation of bone. This can cause the manifestation of osteoporosis. Certain drugs can reduce the ability of the liver to break down glucocorticoids and could lead to an increase in the levels and side effects in the body. On the other hand, some drugs may increase its breakdown and may require a higher dose when used with these drugs. Trolendomycin, erythromycin, clarithromycin, and ketoconazole can reduce the ability of the liver to metabolize corticosteroids, and this may lead to an increase in the levels and side effects of corticosteroids in the body. Phenobarbital, ephedrine, phenytoin, and rifampin may reduce the blood levels of corticosteroids by increasing the breakdown of corticosteroids by the liver. This may necessitate an increase of corticosteroid dose when they are used in combination with these drugs. On the other hand, beta agonists may potentiate steroid-induced repression of some cytokines, while corticosteroids upregulate beta receptor mRNA transcription, thus restoring beta receptor function. As long-acting beta agonists have intrinsic anti-inflammatory effects, combinations of the two drugs have been found to improve asthma control and reduce exacerbation rates. Because of this positive interaction, long-acting beta agonists may have steroid-enhancing or steroid-sparing effects. Thank you for watching this video. Try out this multiple choice question to test your knowledge.